All right, welcome to Unit 4, Lesson 3 homework help, solving equations literally. So let's start with the ready. Perform each operation described in the first column of the table on the inequality -9 is less than 2. Record the work in the second column and state whether the new inequality is true or false in the third column of the table. All right, so our example is here. That's going to be pretty helpful. Let's zoom in just a little bit more. Excellent. So our example is add 3 to both sides. So we had -9 is less than 2, and now it's -9 plus 3 is less than 2 plus 3, and that becomes -6 is less than 5, and that's still true. Okay, so that's what we're going to be doing. We'll do alternating. We'll do green for the first one, purple for the next one, green for the one after that, and so on. So subtract 7 from both sides. All right, so we had -6 is less than. Oh, are we going from -6 is less? Let's make sure. Are we going from -6 is less than 5, or no? We're always going back to this -9 is less than 2. We're always going to start there. Okay. So here we go. -9. Subtract 7 from both sides. It's at -7 is less than 2 minus 7. All right, what's -9 minus 7? That's -16. Is less than, what's 2 minus 7? That's -5. Is -16 less than -5? Yes, it is. That's true. Okay. Switching to purple. Add 15 to both sides. -9 plus 15 is less than 2 plus 15. All right. -9 plus 15, that should give me 6. And is 6 less than, what's 2 plus 15? That's going to be 17. 6 is less than 17. That's true. Back to green. Add -10 to both sides. Add -10. Okay, we can do that. -9. Oh, didn't like that one. -9 plus -10 is less than 2 plus -10. All right. -9 plus -10 is -19. 2 plus -10 is, not equals. I was about to write equals. Is less than, what's 2 plus -10? 2 plus -10 is -8. Is -19 less than -8? It is, so that is still true. That's good. Multiply both sides by 10. Multiply both sides by 10. All right, we have we got to be in purple mode. -9 times 10. That didn't work. Times 10 is less than 2 times 10. -9 times 10 is -90, which is less than 2 times 10 is 20. Is this correct? Yes, -90 is less than 20, so that is still true. Let's go back to the green. Here we go. Divide both sides by 5. All right, -9 divided by 5 is less than 2 divided by 5. All right. So -9 divided by 5, I'm actually going to write this as -9/5. And 2 divided by 5, I'm going to write as 2/5. So if I have -9 of a thing, and I compare that to 2 of a thing, -9/5 is going to be less than 2/5. So this is still true. Uh-oh. All right, let's multiply both sides by -6. Okay. Switching to purple. Here we go. Multiply both sides by -6. -9 times -6 is less than 2 times negative, oh, didn't like that one, 2 times -6. And that's going to become, what's -9 times -6? That is positive 54. And then what's 2 times -6? That's going to be negative 12. Is 54 less than negative 12? It's not, actually. All right, so that didn't work. Okay, that one didn't work. And now divide both sides by 3. Divide both sides by 3. Or sorry, by -3. That is negative. Divide both sides by -3. So let's see, we have -9. Oh, it didn't like that. -9 divided by -3 is less than 2 divided by -3. -9 divided by -3. Well, if we have a negative divided by a negative, those will be canceling each other out. So we'll end up with a positive. So 9 divided by 3 is 3. So this is 3 is less than, and we'll go with 2 divided by -3 is -2/3. Okay, this says that a positive number is less than a negative number. That is impossible, so this is false. All right. Question 2, what operations performed on an inequality will reverse the inequality? Oh, okay, so this is asking basically what operations made the inequality false? Because if an inequality is false, that just means you have to flip it and then it'll become true. So which ones made it false? It was only the last two, right? So multiplying or dividing by negatives. All right, so what operations performed on an inequality will reverse the inequality? And this is going to be multiplying or dividing by a negative number. Multiplying or dividing, oh, that was not well done, or dividing by a negative. All right, and this could be a negative number, or it could be a negative variable, or maybe it's a negative constant. There are a lot of numbers we could, or a lot of things we could fill in the blank there. But if it's negative, that'll flip the inequality. So, okay. For the set portion, solve for the indicated variable, show your work. Solve for the indicated variable, show your work. All right, and that's going to start on the next page. So we're solving for m and showing our work. All right, we can do that. Solve for m. All right, let's start. We'll just copy it down so we have more space. Y equals 7m plus 6. 7m plus 6. And solving for m when we have two unknowns, or two variables, just means make it so that we have m equals something here. But we don't know what that something is. But as long as we have m equals something, and we do all legal math things, this is going to work. So solve for m. So we have to get m by itself. Let's subtract 6 from both sides. Now we're going to have y minus 6 equals 7m. And then we're going to divide both sides by 7. Divide both sides. Divide by 7. Divide by 7. And we should be left with y minus 6 divided by 7 equals m. All right, and that is solved for m. Excellent. All right, we're solving for m again. We're going to do this one in purple. All right, so we need m equals something. That's our goal. right? M equals something. All right, so we start with y equals mx plus b. Our first step is to subtract the b from both sides. Y minus b equals mx. Then we divide both sides by x. Divide both sides by x. Divide by x. Divide by x. Oop. Here we go. So we end up with y minus b divided by x equals m. All right, that is solved for m. Let's keep going. Solve for x. Aha, we're solving for x. And this time we only have one variable. X is the only variable. So we should end up with a number, right? X is the only thing. So when it's alone, we should have x equals some number. All right, so x, nope, can't do it yet. Can't do it yet. I'm jumping the gun. Here we go. 2x, we're just copying it down so we have it in our own writing. 2x divided by 5 minus 9 equals 6. All right, that I said 6, but I wrote 9, and that's not going to happen. That's not going to fly. So, all right, equals 6. Perfect. There we go. First thing we do is add 9 to both sides. Add 9. Add 9. So we end up with 2x divided by 5 equals, what's 6 plus 9? That's 15. All right, now we're going to multiply both sides by 5. Multiply both sides by 5. We should end up with 2x equals, what's 15 times 5? Maybe you can do it in your head, maybe not. It is 75. All right, 2x equals 75, and we're going to continue up here. 2x equals 75. Now what do? We divide both sides by 2. Divide by 2, divide by 2. X equals 75 divided by 2. 75 is not an even number, so we could just keep it as a fraction. 75 divided by 2. We could have that as our solution. Or if you really wanted to make it a decimal, right, we could write x equals 37.5. 37.5. That is also, right, correct. This is a fraction, right? We have it as a fraction or as a decimal, but those are the same number. All right, switching to purple because we're doing multiple in a row here. Solving for x again. All right, let's write it again so we have a little bit more space. 2x over 5. Oh, we have a y in here as well, right? This y means it's going to be a little bit tricky, so we're actually going to have, sorry, not 2. That's not what I meant, right? If we solve for x here, we're going to end up with x equals something, and that something needs to have a y in it. And it might have more than one y, but it needs to have a y in it, because if we get rid of the y, we did something wrong. So here we go. 2x divided by 5 minus 9y equals 6. So the first thing we do is we add 9y to both sides, right? Plus 9y to both sides. Plus 9y plus 9y. Now we should be left with 2x divided by 5, 2x over 5, equals 6 plus 9y. 6 plus 9y. All right, 6 plus 9y. Right, and we can't add the 6 and the 9y together. We can't like condense those or like push those together because it's 6 numbers, right? 6 units sort of on one side and 9 y's on the other. So it's sort of like adding apples and oranges, right? We can't put this variable with a number. We can't make it like 15y or 15 plus y. We can't do that, right? We have 6 1s and 9 y's. So those are like two different categories. So we are going to, let's actually bring this up a row. So we have 2x divided by 5 equals 6 plus 9y. That's what we have right now. Next, we're going to multiply both sides by 5, multiply by 5, and multiply by 5 to get rid of the 5 in the denominator, right? So we have 2x equals, and then we're just going to keep it like this, right? It doesn't really matter. It doesn't say we have to like simplify or not have any parentheses or anything like that. So we'll just have 5 times, and we'll just keep the inside how it was, 6 plus 9y. And then the last thing we're going to do is divide both sides by 2, divide by 2, divide by, that didn't work out. Doesn't always like when I do that. All right, divide by 2. And we should get x by itself equals, and then this should be 5 halves, or 5 over 2, and then 6 plus 9y. Now, we could write, right, this whole thing, we could write this also, I'll write an or. We could write this as x equals, that kind of looks like a y. Hang on. It's not how I draw y's, but it did kind of look like a y, right? So it could be x equals, we could have written it also as 5 times 6 plus 9y, 6 plus 9y divided by 2, right? This also would have worked, right? Either one of these would have worked. If you wanted to write it as 5 halves times the thing, or 5 times the thing divided by 2, they're going to be the same. It's really just preference, personal preference, and like what's your style? Like how do you want to write that? So number 9, we only have an x. That's the only variable, so we should be able to get to a number. So let's switch back to the green here, and let's take it away. So the first thing we're going to do is multiply by the reciprocal, right? So this is this 3/4. What we're going to want to do is first multiply by the reciprocal, which is 4/3, right? So we're going to do that to both sides, times 4/3, right? Because if we multiply 3/4 by 4/3, it'll become 12 over 12, which is just 1, so that's like it going away. So when we do that, we should be left with x minus 2 on one side, and then what's 12 times 4/3? Well, 12 times 4 is 48. And then 12, and then we just leave it over 3, right? 48 over 3. Okay. Now we might want to rewrite this right now because 48 divided by 3 is actually, right, and let's put a note, we'll put a note over here, right, a little star here. 48 divided by 3 is equal to 16. All right, so we're actually going to rewrite this as 16, right? So we're just going to write x minus 2 equals 16. All right, x minus 2 equals 16. Now we are going to bring this across, so we have a little more space. X minus 2 equals 16, and we're going to add 2 to both sides, and now we get x equals 18. All right, so there we go. That is solved for x. Perfect. All right, that's the bottom of the page. Let's go. Oh, we're doing one more. Here we go. Solving for x again. Looks like the same numbers. So we can sort of do this easily to start off, but since we do have this y here, we know that our answer is going to be, right, we'll make a little note. We're looking for x equals something that has a y in it, right? Something that has a y in it. So our first step, let's multiply both sides by the reciprocal 4/3. That's our first thing, right? Because it's the only thing not in parentheses. So multiply by 4/3, multiply by 4/3. We just did on the previous page 12 times 4/3, we said was 48/3, which is the same as 16. So we're just going to cut right to that 16 part. So we're going to have x minus 2y. And that's just not how I write y's, so we're not going to have that, right? I always write y's like this. X minus 2y equals 16. Now what we're going to do is we're going to add the 2y to both sides. Add 2y, add 2y. That looks like one thing. Here we go, add 2y. And we end up with x equals, gosh, I can't write on this today. X equals 16 plus 2y. All right, and that is going to be our solution. All right, because we wanted to solve for x, so we have x equals something, and that something does indeed have a y in it, so that's exactly what we wanted to get. All right. Oh, the go section. Here we go. Locate, oh, no pun intended there on the go part. Locate the x-intercept and the y-intercept in the table, write each as an ordered pair. Okay, so for each one, we should have an x-intercept. Oh, perfect. It has it right down here, right? We should have an x-intercept and a y-intercept. So we'll do these in two different colors. How about that? All right, so our x-intercept is wherever the y value is 0, right? So this is something tricky, but as soon as you, right, just remember it, like the x value, right, x-intercept means y equals 0. Y-intercept means x equals 0, because our axes are always on the 0 lines of the opposite variable. So let's do the x-intercept first. We're looking for y equals 0. So we go down the line and we see y equals 0 right here, right? In our y column, y equals 0 right there. So our x-intercept is going to be 2, 0. Right? Another way to think about it is x-intercept means the only interesting number should be the x, right? The y is going to be 0. We're only interested in x, and in this case, the x is 2. So we have 2, 0 there. And then the y-intercept, well, we're looking for, right, whenever x is 0, right, that's going to happen right here. So 0, 4, right? Let's move on to the next one, number 12. All right, we'll do the, oh, it seems like the x and y-intercept slot is on the next page. So we will just write them here. We'll just write it here. The x-intercept and the y-intercept. Oop. And the y-intercept. There we go. All right, now we have space for those. Let's switch back to green. And we'll do the x-intercept first. So we're looking for y equals 0. I found that down here. So our x-intercept is 18, 0. 18, 0. And our y-intercept, it's actually this first one, is 0, -6. 0, -6. All right. So we got 12 done, 11 and 12 done. And then we'll move over. Oh, we don't need to do 13. Don't need to do 14. We'll keep going. Aha, 15. Oh, we need to know the instructions. Hang on. Locate the x and y intercept in the graph, write each as an ordered pair. Oh, perfect. So it's still locating x and y intercepts, but instead of a table, we're doing a graph now. All right, so here's our graph. All right, so our y-intercept we'll do in green. So our y-intercept is if we trace over the y-axis, right? Where do we cut across the line? And it looks like it's right there. Oh, not a new note. So that is the y-intercept. Right? That is our y-intercept because we're on the y-axis. Oh, we didn't need to do that because there's a spot for it down below. So that is the y-intercept. And that y-intercept happens at the point, it looks like 0 is x. I mean, that makes sense, right? 0, comma, and that looks to be 4 on the y-axis. So 4, 0, comma 4. All right, the x-intercept, we're going to trace the x-axis, which is y equals 0, and it looks like we crossed right here. This looks to be x equals -3 and y equals 0. Right? -3, comma 0. Right? All right. Moving on. Ooh, okay. One more portion. Solve each equation for x. Provide the justifications for each step. See the first example as a reminder for the types of justifications that might be used. All right, so we're always going to have an equation to the left and then a justification to the right of it. All right, addition property of equality or division property of equality. So I have a feeling we're only going to be using properties of equality here. But let's go see. 17. All right, we're going to do this we'll do it in purple. We're already in purple, so we'll just do it in purple. That's fine. Solving for x. All right, so the first thing we're going to do is subtract 11 from both sides. -11, -11. And this is because of the subtraction property of equality. The subtraction property of equality. And we'll write out equality all the way, because if I write just equal, then that might be confusing. So now we have -27 equals, and now it should just be 3x. Oh, it did not write that for me. There we go, 3x. All right, now what are we going to do? Well, we are going to not subtract. We're not subtracting here. What are we doing? We're dividing. Divide this side by 3 to get the x alone, which means we also have to divide the other side by 3. And this uses the division, right? The division property of equality. Division property of equality. All right, and now we have, what's -27 divided by 3? That should be -9. And then 3x divided by 3 should just be x. So -9 equals x. Perfect. And onto the last page. Oh, it looks like we're going to do 3 more of these. Ooh, this is exciting. All right. We have x's on both sides. So we have to pick one side to have the x's and one side to have the numbers. So first thing we're going to do is I'm going to pick our x's to go on this side, right? I'm just going to label these. I'm going to have the x's on this side and the numbers on this side. So we're going to have x on one side and number on another. All right. So in order to get there, let's move the number. Let's move the number from the left side over to the right side. All right. So the way we're going to do that is subtract the 3, right, from both sides. Oh, and get the lights to turn on again, right? It actually didn't look so bad. on the recording, but that's okay. So negative 3, or sorry, subtract 3 from both sides. So we have 6x by itself over here equals, and this should become x. Oh, this should become x plus 15, right? Because we had 18 and we're taking away 3. So x plus 15. And the reason we do that is the subtraction property of equality. Prop of, and I'm just going to write the E now. You know what I mean. All right, subtraction prop of equality, or subtraction property of equality. There we go. All right, so here we are. Now let's move the x to the other side, right? So now we have to subtract the x from the right side and from the left side. So we're going to end up with 5x, right? Only 5x equals, we took away the x here, so there's no x's left. So it's just 15. 5x equals 15. Same thing, right? This is also the subtraction property of equality, right? That same thing. And then our last step is going to be divide by 5. Divide by 5, both sides. All right, so we have x equals, and 15 divided by 5 is just 3. So we get x equals 3 as our solution. And the reason we could do this is the division property of equality. Here we go. So that's the first one done on this page. Aha. What are we trying to solve for here? Did it say we're always solving for x, perhaps? Did it say that? Let's go check, because there's an x and a y here. So let's make sure we're doing the right thing. Where is it? Solve each equation for x. Good. Solve each equation for x. We're just going to underline that. All right. Perfect. So we are trying to solve for x. I was a little bit concerned because there is a y in this problem, which we will do in purple. So there's a y in this problem, and I just wanted to make sure that we are trying to solve for x. All right, so we are going to have, let's just keep the x on the side that it's on. So we're going to have x's equal, like x on one side, and then equal to y and number on the other, right? Y and numbers, right? That's a comma. If you can't tell, that is a comma. Let me rewrite this. It needs to be equal to y and numbers on the other side. So x on one side, y and numbers on the other side. So let's first get that y and move to the other side. So we're going to subtract 3y from both sides. That is not how I like to write my y's. This is the second time this video, I think. Just not a fan of y's like that. There we go. Negative 3y from both sides, right? Minus 3y, minus 3y. Okay. And this is the subtraction property of equality. Now we should have 12x left on this side equals, and then we should have negative 3y plus 15. We could have also written this as 15 minus 3y. We could have done that, but it's going to be the same, right? Because there's the commutative property of addition and subtraction, or of addition, which means that we can always change the order of addition, right? So instead of 15 plus negative 3y, we can have negative 3y plus 15. Those are going to be the same. So we are on to the next step, which we're going to, well, we have this x, but there's a 12 multiplying with it, so we have to divide by 12 on both sides. So this is going to use the division property of equality, right? There's all these properties of equalities. I just don't want to write them every single time. I mean, you are more than welcome to, right? Absolutely do. But I would write it if I was on paper, but the board trying to write like words and sentences is just a pain. So we're not going to do that, but that's okay. All right, we divided by 12. What does that leave us with? It leaves us with an x on one side. That's what we wanted. And then the other side, let's well, we'll be a little bit creative with this. So we'll first write it as negative 3y plus 15 all divided by 12. So this is correct. And for those of you who are looking for a little bit of a challenge, you can try to simplify this even further. And I will show you that the way that would happen, right? So I'll write or, and then we're going to have x equals. So if you want a challenge, pause the video right now, because I'm about to show. Negative 3 divided by 12 is the same as, can we divide? All right, so this is actually going to be negative 1/4. This is going to be negative 1/4 y, so negative y over 4 plus, and then this is actually going to be, let's see, 5/4. Right, and this is actually going to be 5/4. Right, so, right, 15 over 12 is the same as 5 divided by 4. So we can do that, and we could have left it as just x equals negative y plus 5 all divided by 4. That would have worked as well. Right, all of these are the same. But that's fine. Okay, moving on to the next one. Here we go. Solving for x, and now we have a capital B. So let's just make a little note that we're going to have the x's are going to stay on the left, and the b's and the numbers are going to be on the right. How about that? That'll work? All right. It's a little bit tricky, I suppose, but this is actually just a one-step problem. So with that little hint, can you get it, right? This is a one-step problem. All right. And that one step is we are going to divide both sides by b plus 7. Right? Divide both sides by this b plus 7. Now you might think that is just awful. We have this x, right, times b plus 7, right? We should do something more elegant. And the simple fact of the matter is that all we want to do in these problems is get x by itself, which this will accomplish, right? If we divide the b plus 7, this is x times b plus 7. So if we move the b plus 7 to the other side, if we get rid of it, right, from the left-hand side, all we're left with is x, and the other side might be a little bit messy, but that is okay. We can deal with that later if we need to, but in the case of this problem, we do not need to. So the other side will be 9 divided by b plus 7. And what's nice is that because the division bar, the fraction bar, actually covers the whole b plus 7, we do not need parentheses anymore, right? It's sort of implied by the wide bar that b plus 7 is the denominator all by itself. And the reason for this is the division property of equality. There we go. Perfect. So one-step problem, it's messy. It looked kind of ugly, but that will work totally fine. And that actually wraps up this Unit 4, Lesson 3 homework help.